Hello everyone! So today I wanted to make a different kind of video from the ones that I used to make, the presentation style videos that I honestly wasn't super happy with. They're not super dynamic. So I decided to try something closer to what I do on live streams, talking directly to the camera. I have my assistant sleeping behind me, showing a lot more of the code, a lot more of the process of what we're doing. Because actually today, kind of the entire point of the video is to show that you don't need much code to do Git remotes. So I kind of want to demystify how Git remotes work. Although I do expect that you have some knowledge of how Git itself works, which otherwise you're not going to understand what we're talking about, but it's also not super relevant to you. But if that's the case for you and you're using zip files to back up your projects, look into Git, look at how it works. It's so much better. Trust me. Trust me. Do that. Learn how it works. Come back to this because maybe this is not going to be super relevant, but I do still think you should be using Git or some alternative. Git is not perfect for every use case, so there are alternatives to Git as well. But yeah. All right. So here's the thing. Git is version control, right? When I'm working on a code project, Git allows me to do backups of that project, do versions of that project. So every time I make a change, I just make a new version of it, a new commit, and it keeps track of all the commits. I can go back and forth in the history. I can have different alternatives as in the form of branches, all of these different really useful things, especially when it comes to working with other people, but also when it comes to working within your own project. For example, I'm working on something and it turns out that something that I already built a while ago is broken now. How did that break? I don't know. When I worked on it, it was working. Now it doesn't work anymore. I can go through the history and find where it broke, which is going to make it a lot easier to fix it. So that's kind of the type of thing that Git makes really useful. Also, like, oh, I made something, but I kind of don't like it. Let me revert it. That type of stuff, Git is very, very useful. And of course, when I want to publish my projects somewhere, I want to have a backup of my projects somewhere, or I want to share them with other people, or I want to make it so that two people can work on the same project, Git remotes can be really useful. So GitHub is usually the go-to for this type of thing, but GitHub has had some reliability issues lately, famously reliability issues, and so people are looking at alternatives. Codeberg is one, but honestly, Codeberg itself, I've tried it, I like it, but it also has its own reliability issues. But I was thinking about that and I thought, you really don't need anything besides Git itself to have Git remotes. Nothing else. And actually, these are all my projects that I have on GitHub right now. A few of them are also on Codeberg. Not all of them, but a few of them are also on Codeberg. But when I make a commit and I push that commit to GitHub, I don't do it directly from this computer to GitHub. I actually go through a server that I have, a local server. I push to that and it pushes to GitHub and also to Codeberg. The main reason I did that is that I have two different places in which I publish my stuff, and it handles doing that for me. So I don't have to push twice, I don't have to pull twice. It handles all that synchronization for me. But even if that's not the case, just to understand how Git remotes work, I think let's look into this. Let's see how they work. All right, so let's say that I'm working on a project. I have an empty folder here that's going to host our project. I'm going to create our project. I'm going to call it project because I'm very innovative like that. I'm going to go into it and I'm going to create a Git repository inside that project. Now, I'm in Z as the code editor, but it has its own Git client. I could do all the stuff from here. See, I could initialize the repository by just pressing this button, but I'm going to be doing it through the command line because the command line is, first off, a lot more explicit, so it allows us to see what we're doing a lot better. And also, Zed's Git client is not the most reliable, especially lately. It's just been breaking. So I'm going to be doing it through the command line. And also, if you don't use Zed, maybe it won't work the same way if you use something like SourceTree for Git, if you use LazyGit, if you use VS Code's Git client, whatever. But if you use the command line, it's the same for everybody, because Git works the same way. So we're going to be using that. All right, so I have my project. Before I even begin, I'm going to, working on the actual project, I'm going to create the repository for it. And there we have it, and even Zed has picked it up. Right, so I am going to be on a branch called main by default. Used to be called master, they renamed it to main now. Some old projects may still have master. But yeah, we're on a branch called main right now, and there's nothing happening on it. We are on branch main, no commits yet, nothing to commit. All right, so let's begin with an initial commit, just an empty commit to have a starting point to our project. So we're going to do git commit m initial commit, and we're going to need to use allow empty because we're not actually committing anything. So it doesn't allow it by default, but we can allow it with this. There we go, we have an initial commit. Now we can look at the history here in Z or git log, and there is my initial commit. And we have this thing here, which by the way starts with face, and ironically is the head right now. So the face is the head, but that's not relevant. That's just the hash of my commit starts with face. And yeah, it's just at this point in history, this is what the code looked like. And okay, so there's no code, there's nothing in this repository. So let's create a main file and open it in Z, and we're going to, I don't know, include stdio, and we're going to create a main function, and inside of that main function we're going to do hello world and -n because /n because stdio requires that. And there we have it. We could run it, but that's really not relevant, so it doesn't matter. Okay, after a long day's work, I finally introduced the hello world feature to my project. So it's time to do a commit to, you know, create a version at this point in time. Git commit, wait, no, before we do that, we have to add it, right? So if we look at it visually, which I am going to be looking at it visually because it's helpful, git add everything is dot, or git add main.c if we want to add specific things. There we go. And then git commit m added main. And there we go. One file changed, 5 insertions, create mode for main.c, where we inserted 5 lines of code. Cool. If we remove lines of code, it's going to start keeping track of all that stuff. We added more lines, we removed lines, all of that stuff. So it's going to be able to go through the history. That's the very useful thing about Git. If we do git log again, there it is. Now, okay, I want to make it available somewhere. Let's say GitHub, right? Well, I want to make it available somewhere. GitHub is the go-to. But we're going to be looking at alternatives, meaning not even alternatives, just doing our own thing, doing our own remote. But if I were on GitHub, I would go here to my profile, new. I would create a new project. I'm going to call it project. I already did this once, so it auto-completed. I'm going to make it a private thing just because I'm just using this as an example. It's not a real project that I'm making. I'm going to be creating it. And GitHub's a bit slow nowadays, but here it's going to tell me how to get started. Quick setup for your project. If you've done this kind of thing before, just get the URL, you know what to do. Otherwise, you can create the repository on the command line if you don't have any code, or you can push to it. This is what we care about because we already have some code, right? So we could just run git remote add origin, this whole thing, then git branch m main, which we wouldn't even need to run, and git push u origin main, and then our code would become available here on GitHub. But we don't want to do that. We want to host our own thing, right? So let's do that. All right, here's the interesting thing. This project.git, what is it? What type of thing is it? It's just a Git repository, nothing else but a Git repository. So actually, if we go into our project and we do ls, we're going to see the main.c, just a file that we created as we expect. But if we look at hidden files, we're also going to see a .git folder alongside the dot and dot that Unix-like systems tend to have. If we go into the .git folder, we're going to see all of these different things: branches, commit, edit message, config, description, head, hooks, all of these things. This here, this folder and its contents is all the data that Git is using to keep track of what my repository looks like. You know, on this machine, in this repository. This is the .git folder for it. And spoiler alert, so is this. It's just this thing, specifically the .git folder. Right, so right now, the project folder contains both the code itself, as it looks right now, and the .git folder. In fact, if I go back to my initial commit, if I do git checkout in the actual project and not inside the git folder, then now I am in a detached head state again. Git stuff doesn't really matter, but look at my project. The main.c is gone because we've reverted back to what it looked like when I did this, which was just an empty repository. However, the .git folder is still there, and the main.c is actually there. All we did is go back in history using that .git folder. Now I can do git checkout main, or even what it tells me to do here, git switch dash, and it is going to return me back to the main branch where the commit actually is. Right. So essentially, what we have on GitHub and what we're going to have in our own remote is the Git folder and nothing else. This is called a bare repo. The difference is that it doesn't have a work tree or a working tree, which is actually the error that it showed me before, even though I probably edited out the part where it happened. It tells me that I need to run it in a work tree. I'm not in a work tree. I'm in just the Git repository. A work tree is essentially the code as it actually looks like, so I can actually work on it. You know, that's what a work tree is. A bare repository is just the same as this, but without the work tree, just the Git repository, which is also why if we look at the GitHub URL here at the end, it has project.git. Project is the name that I gave it. .git. I'm assuming that using .git here is just convention. You technically don't need to use it, but you probably want to use it. But the thing is, instead of pushing to GitHub, we're going to push to another repository that we create. I'm going to do it in my own local machine. If you want to do a remote, it doesn't make sense for your remote to be on your local machine for, you know, even just the names tell you that this doesn't make much sense. But for example, you could have it on a local server, which is what I do. So in your local server or whatever, I'm going to be doing it in the same Gitter folder, but not in the project. I'm going to be outside of the folder of the project, and I'm going to do git init and then dash bare. So again, no work tree. You can't actually write code in this repository, but it is still a Git repository. I'm going to do project.git. Let's call it project remote, just to make it more explicit. And there we go. It created a folder called project remote.git. And inside of it, branches, hooks, info, objects, ref, config, description, and head. The same things that we saw in the Git folder of this project. Right, so let's bring this shell back into the project itself, but then let's check out that project remote, and I cannot type today, there we go, or ever actually. This is a completely empty repository right now. If I do git log, there's actually nothing. Your current branch doesn't have any commits. So let's give it some commits. Let's push to it, like we would on GitHub. The setup is the exact same as it is here, except here GitHub is showing me an SSH URL. It could also show me an HTTPS URL, which is literally the URL that I used to look at it on the website, but with a .git at the end, which just redirects me back here if I try to access it in a browser. Right, but yeah, instead of using that, we're just going to point to this repository, which is on my local file system. So I'm going to push to it using a relative directory, but the command is the same. Git remote add origin, and then the URL, which is outside one directory, then project remote.git. I can even autocomplete. Right, and here what I'm doing is I'm adding a new remote called origin. So you can actually change this to whatever name you want. Origin is, again, just convention. We tend to call it that. Again, maybe there's some default behavior if you call it origin. I assume there probably is, but it doesn't really matter. You can give it whatever name you want. We're going to do that. And now that's not enough. We need to push to it. And if we push to it, there we go, blah, 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 blah. Point is, we've pushed to it, and we're tracking origin main. Main is now tracking main branch on this thing. And if we do a git log on the project remote now, there we have the two commits that we did, the face one and this one. But we can't check them out. We can't write the code. You see the main.c is nowhere to be found in this one, only in this one, because this is a bare repo. It doesn't have the main.c. It just has the .git folder and its contents. Only the Git data, not the Git project, not the actual project, which is why it works great as a remote. Now, of course, maybe a disclaimer that I should have put earlier, this will only work if all you care about is having a remote. If we look at the GitHub website, and also codeberg and most of these other things work the same way. We have issues, we have pull requests, we have actions, all of these interesting things. And all of these other ones that, honestly, I don't even use that much, but they are there. And for example, if my project were public, people could use my project and, oh, there's a bug, let me create an issue. Or, oh, I want to help fix the bug, so let me create a pull request. This is GitHub specific content. It is not part of Git. Actually, some older Git projects like the Linux kernel and probably Git itself, though I don't know, don't use pull requests. Instead, they just apply patches in a much more manual way, but it kind of works the same way, just without the neat little web interface. If you want the web interface, then this is probably not for you. You probably do want to use either GitHub, codeberg, or a self-hosted alternative that gives you, the neat little interface. Or if you want to build it yourself, you also can. You're going to need to have issues and pull requests stored somewhere. You can put them in the .git folder as far as I know. But yeah, you're going to need that stuff. However, if all you want is a remote that you go, hey, I just made a commit, I want to make it available there. Anyone who has access to that remote can pull my changes. This is perfect. All right. And as a matter of fact, here's the thing. This is a Git repository with the .git providing the data for it. This is also a Git repository. It works in the exact same way. The only difference is I can't make changes to it. I don't have a work tree. So again, if you know a little bit more about Git, if you're a Git power user, you know what a work tree is. You probably know all that I'm saying, actually, if you're a power user. But anything that you need a work tree to do, you can't do in here. But besides that, it is just a Git repository, which means it itself can have a remote. So I can do git remote, and here I can actually copy the exact same thing that GitHub told me to do. This thing. Although I am going to be changing its name to upstream. This is really just convention to point to, oh, I'm a remote, this is another remote, all I'm doing is just push into it. Although upstream is not really the correct name, because upstream implies that that is the source of truth, if you will, and we're just getting changes from upstream, whereas really we are the upstream. So would this be downstream maybe? I don't know. I'm still going to call it upstream. I'm going to add it, but I can push to it, right? I can push to it, and there we go. Now if I refresh my page, if GitHub wants to refresh my page, GitHub, please. This is why I'm making this video, so you don't have to go through this. Is my internet down? No, internet's working fine. It's just GitHub. Okay, so this is the exact reason we don't want to do this. Or we want to do this, rather, instead of using GitHub. And actually, my local server is the bare repo, and it has also an upstream like I did here. So I push to it, it pushes to GitHub. If GitHub has issues, I don't notice it because the server notices. It gets frustrated at this, but I don't have to because all I do is push to my server, which is, not gonna lie, it's starting to be a little bit slow nowadays, but that's a skill issue of my server. It's not really anything else. And GitHub is just refusing to connect today. So take my word for it, I guess. This is the second time I filmed this video. I'm not filming it a third time. So take my word for it. Hopefully it'll work later, I guess. And we can assume that my changes will be reflected in the project if GitHub ever decides to start working again. According to GitHub, everything is fine right now. And it's okay, finally it loaded. That took a while. But there is my main.c. And as you can see, what I did is I pushed to my remote, and my remote pushed to GitHub. Now, here's the interesting part about that. You can technically automate this. Now, the scripts to automate this that I've used in my server, which by the way I've called getter, that's why I'm using this name here, are a little bit more complex, and I don't really want to go into them. But here in the project remote.git, I have these hooks, and you can see on their names that they are simply actions that are going to run at specific when something triggers them. And the name usually tells you what triggers them. For example, pre-push. When I do a git push from here, when I do git push, it is going to run the pre-push. And the pre-push is, it actually gives me a sample so I can look at what it does. It's going to run all this code, which is just a bash script, by the way. It is going to do this thing. And what this one does, if I'm not mistaken, is it's going to prevent push of commits where the log message starts with WIP. So the log message, which by the way, when I first tried to film this video, I tried to trigger this action and it didn't. And I just realized why. It's because it's the message that it checks. Whereas the title of my commit is the one that contained WIP. So take my word for it. I don't want to go through the entire thing again. But if you want to enable this functionality, what you do is you rename this from prepush.sample to just prepush. So it becomes just a bash script, nothing else. And then, you know, you can get rid of the whole explanation that Git gives you for it and modify the script to do whatever you want. And now whenever you push from your project where you're actually working, you're making a push to your remote, you can check that that push is correct according to some rules that you come up with. And if it isn't, you can even reject the push. So it's not allowed until it meets your criteria. It can really be that simple. I'm actually using pre-push to synchronize my local server and GitHub. Because here's the thing. I'm working on my projects. I'm the one making commits. I'm the one pushing code. But occasionally, there's going to be code on GitHub or on codeberg. For example, if someone makes a pull request, I accept the pull request. Now their code goes into my repo on GitHub, but not on my local machine. Right, so what I do is on pre-push in my local server, I check, is there anything on the remote that I don't have? And if that's the case, reject the push until it's there as well. Going through the local server. The local server will pull it into its changes, and I will pull it from the local server to my machine. So the code to do that is a little bit more complex. Although I have to admit, actually, this works, just doing a git fetch, though it kind of shouldn't. But the thing is that what I'm doing is rejecting changes that the local server doesn't have. Because actually that functionality of I don't allow you to push until you've pulled my changes is standard on Git. I don't think you need to do anything special to have that. But that's not really what I'm doing. It's I'm not allowing you to push until I have the changes from GitHub. So git fetch is checking from its remotes, from upstream, are there any changes that you have? And normally, this alone wouldn't be enough to just reject the... This alone wouldn't be enough to reject the changes, the push, rather. But the thing is, if git fetch actually finds something on the remote, it is going to try to update the current repository on my local server with its chain, with the commit hashes, so these things, to keep track of that, to inform itself locally without actually pulling the code or doing any of that. By the way, there's something on upstream that you don't have, right? So in order to do that, it just fetches the hashes, nothing else. But pre-push actually runs in a quarantined environment. It's not allowed to make changes to the repo. Pre-push works like that. There is a post-push, if I'm not mistaken, which is allowed to do that, but pre-push is not. And because of that, when git fetch realizes, oh, there's something on GitHub that I don't have, let me update, that part is rejected, the command fails, and it therefore fails the entire pre-push hook, so I cannot push until the server has synchronized itself with GitHub, which, by the way, I just have something that does that automatically. I was surprised that this worked, but yeah, not really important what you put in pre-push. It's just a special thing that you might want to put up there if you have something important, like some kind of special functionality like I do. I'm synchronizing my remote to GitHub and to codeberg, right? So if there's any changes on there, I need to pull them and then pull them into the local machine, and then the local machine can push. But if the changes haven't been pulled from upstream, reject until they have. And also tell the local server to, fetch them quickly, so that I can actually make my push as quickly as possible. Right, so that's just an example of what you can do with pre-push. Although I have to say, what I have in my local server is in a Git repository. Like the way that it works, these hooks and all that stuff is in a Git repository, but I don't think I have it on GitHub or anywhere, so I'm not gonna link it unless people want it. If you want it, let me know. I will put it on GitHub and actually link it. But right now it is hosted just on my local server. Right, but the point of this whole thing is you really don't need anything other than a separate Git repository to push to. Right, technically you don't even need it to be a bare repo, though I don't know why you wouldn't make it a bare repo. I just tried making it not a bare repo, and it technically you can. I have done it, but you shouldn't. It's a little bit harder to do because if it's not a bare repo, it is assumed to be its own little standalone thing. Bare repo is specific for remotes. But yeah, that's really all it takes. So you have all of these hooks. And also you have all of these hooks for pre-push, pre-merge, pre-commit, pre-apply patch, post-update, all of these. There may be even more, I'm honestly not sure. Maybe you can read the manual page for Git or just look it up, which is, by the way, the best way to find out about these things. To see what you should be able to do. And or what you can do with these hooks, which again just run at specific times as you're doing different operations on your repository, and they're hosted in your repo, in your remote repo, which means you just get them for free by just making this your remote repo with the scripts there. And it gives you all of these samples here. All right, so this is actually git.dferrari.com, which is literally just doesn't really exist. It's just what I call my local server. In etc hosts, I have an entry to resolve this to the IP of that server, the local IP of that server. And here are a bunch of repositories that I created in here, but the important part is DFS, which is the actual repository that hosts most of, if not all of, the projects that I have on here. And we can look at one of them. For example, the one for my, there's probably some garbage in this folder as well that isn't really supposed to be there from when I was building the thing, sometimes faux pas, and so it stays there. But let's look, for example, at the one for my operating system. This is the bare repo for it. You can't actually work on it, but this machine, when I make a commit, pushes to this repository, and this repository has these two scripts, post-receive and pre-receive. Post-receive, I think, doesn't come in the samples, at least not in the one that I used. And here's what it looks like. Again, it's a little bit more complex, but on pre-receive, yeah. First off, if we don't have an upstream URL, we don't do any of this stuff. Then we're going to check against the upstream remote. So is there anything on GitHub or codeberg that we need to fetch first? That's the thing. And we use a file called await sync to indicate that there is, that we're pending the synchronizing operation. Because like I said, the script is not allowed to actually synchronize. Just check if there's something to synchronize. So what it is going to do is, first off, do we have this pending little file, which I'm using as a flag? Do we have it? If so, we're pending sync. So we already know that there's something on the upstream that we're waiting for. So let's just wait for the sync to be done. which is handled by just another service running on the local server. Otherwise, run git fetch on the upstream, silence the errors, because otherwise those errors are going to look on this machine. They're going to show on this machine, which isn't really what we want. So we silence them. If that returns 0, it's because it never tried to update refs, so it doesn't have anything on the upstream. But if there is, this command will actually fail, and if it fails, then we're going to create that await sync file. We're going to say upstream changes not synced yet, awaiting sync. Then I think this is I just realized that the message is not correct. Just awaiting sync, please wait, or something like that should have been the message. And then exits 1, which shows an error, rejects my entire push. So if this happens, or if this happens, then it will reject the entire push. And then I'm doing some extra functionality, so I have this push sync thing here, and it returns with 0. Now, full disclosure, git fetch always returns 0 if it succeeds. Whether there's changes in the remote or not, will always return 0. There's some extra logic that you need to do in order to know if there's actual changes or not. The only reason that this whole thing works by just running git fetch is because of the whole quarantine thing. Git fetch is not allowed to update the state of the repository, so if there's something on upstream and it tries to do that, it fails. That's why it works. In reality, well, in reality this works, but it's a little bit of a hack. But what I'm doing is I'm using a limitation to my favor. So it's a hack, but not a bad one, necessarily. But yeah, full disclosure that this is not how git fetch will work normally. It won't return error codes at all if there's any changes. If it succeeded, it will return true. Also, if GitHub is down, this may return true, may return an error, for example. Although, I have to say, usually it's worked. And also, I would like to make this more complex so that it still accepts the change, but does this thing, but I'm not sure. That's adding too much complexity for my liking. I don't mind doing it this way, so it's fine. And then I have a post-receive hook that literally just pushes whatever changes it just did to GitHub and codeberg and any other remotes that I might have. So in the future I decide, okay, I'm going to host to GitHub, I'm going to host to codeberg, and I'm going to host to another platform. Then I just add that platform as another remote and it will push to it. And I'm also using mirror here, which is a little bit of a dangerous flag. What it does is it says, hey, I have the truth of what this repository looks like. I don't care what yours looks like. You're a mirror, so there, this is what it looks like. So if there's any changes on GitHub that this server doesn't have, and somehow this runs, those changes will be lost. I'm pretty sure. Let's make sure I never confirm that, but I'm pretty sure that's how it works. Anyway, that is literally all it takes to host a local Git server. And again, I'm just using it as a proxy between me and codeberg and me and GitHub. That's the cool thing about it. Again, if you want stuff like what GitHub gives you, pull requests, issues, actions even, then you will need those. There are actually projects that allow you to host Git with a nice, neat little website where you can actually browse the code, which again, from what we saw, you cannot normally browse the code in a bare repo, but with a little bit of extra stuff, you can. You can even switch between all the branches, look at all the commits, look at all the pull requests. It gives you a full Git experience. That's not what we have here. What we have is just a very simple Git remote that we just push to. And then it pushes to GitHub, it pushes to codeberg, or it doesn't even do that. There's a couple repositories where they're completely local. They're just on my local server. That's it. That's all you need. All right, so hopefully this new format of video allows me to make more videos explaining stuff. Now this one was 0 code except for the bash script, which is not exactly the kind of code that I like to write. But yeah, I want to try doing this kind of like again, more video where I talk. Got my assistant behind him. He woke up right now, so pointing him out again. Where I go more in depth into stuff instead of just explaining it with, you know, a kind of presentation style, which is fine, but honestly, not my favorite type of content to produce. And yeah, let's see if this works.